Okay, in this video what we're going to do is going to go over Chapter 7 review. I'm going to start with question number 1, where we simplify each radical. And as we have learned, what we're trying to do is to break these down into perfect square factors. So there's a number in 900. Actually, there's a couple of them, but let's go with the easy one. 9 times 100 are two perfect squares that I can take and break that down into. And then I can, again, keep going on the a to the 4th and the b to the 6th. And, you know, this is something you can start doing in your heads, and hopefully you are, but for those of you who are still struggling, just follow along. The number in the crook of the symbol is a 2, so we're looking for the square root. Well, if you take the square root of 9, you get 3, and the square root of 100, you get 10. And this is all multiplication, so 3 times 10 is going to give us 30. Next, I'm going to take a look at the a to the 4th. For every 2 of a kind, we can remove 1, and so we've got 2 pairs there and no remainders, and we've got 3 pairs in the 6. Okay, so that would be the answer to 1. In number 2, the number in the crook of the symbol is a 3, and so we want to break these into groups of 3. And again, you don't have to separate these out. This is just for those of you that just need to see each one as a separate entity, I should say. And let's just do the cube root of x to the 12. So we're looking for factors in groups of 3. 64 happens to be a perfect cube. It can be written as 4 cubed, but this is negative, so it's going to be negative 4 quantity cubed, and there's a 3 here. When this number matches the number in the crook of the symbol, they cancel each other out, and so we're going to have a negative 4. And then how many groups of 3 are there in 12? Well, basically all you have to do is divide 12 by 4. Excuse me, 12 by 3, and you get 4. So it's going to be negative 4x to the 4th power. No remainders left, so there would be nothing left underneath the radical sign. Let's move on to question number 3. Again, we're looking for square roots, so the perfect square factor in 32 would be 16, and its remainder would be 2. The square root of 16 is 4. And again, we're looking for pairs of 2. When we divide 2 into the 4, we get s squared. And 2 into 2, we get t. And then we're just going to have the square root of 2. That's the only thing that's left underneath the radical because it doesn't have a partner. Alright, so moving on to question number 4. This time we need groups of 4. So some of you may struggle with that 81 a little bit. But if you think about it, don't think too hard. 81 happens to be 3 to the 4th. I just know that just simply by 9 times 9 is 81, and I can break 9 into 3 times 3. So again, when this number matches this number here, they cancel each other out. They're inverses of each other. So it's just going to be 3. And now, again, if you take the 4 into the 12, you're going to get x cubed. And then 4 into 36 gives you y to the 9th. And again, there were no remainders left over on any of these radicals. Let's move to the next page. This time in number 5, the instructions are simplify each expression and rationalize all denominators. So in the first one, number 5, we see we have 7 minus 2 root 3 and 7 plus 2 root 3. Those are conjugates of each other, and when you have something in the a plus b, a minus b template, the shortcut way of multiplying this out is just taking a squared and subtracting b squared. A stands for the first term in the binomial, so we can take 49, and then b squared would be this number squared here. Well, you've got to square both components of that and then simplify. The square of 2 is 4, the square of 3 is 9. But we know that the square root of 9 is 3. So this will be 49 minus 4 times 3, which is 12. And so the final answer is 37. For those of you who don't like the shortcut, you know what? Go ahead and FOIL it out. Knock yourself out. It'll not hurt you to do that. Okay, so question number 6. Again, we're multiplying these together. It's very much like numbers 1 through 4. We want to multiply our numbers together. So that's going to give us square root of 36. And I already see what's going to happen there. When I join my x's together, that's going to be x to the 4th. And I'm going to put these together. I'm going to extend that square root. Whoops. And make that y squared. Well, the square root of 36 is simply 6. And again, the number in the crook of the symbol implies 2. So when 2 goes into 4, you get x squared and y. And that is your final answer. Number 7 is an adding and subtracting question. And so if you'll remember, in order to combine, you must be the same kind. And in this case, none of these are the same kind. However, they can each be simplified. Well, not each of them. The first and the last one can be. Because there are perfect square factors embedded in each of these numbers. So again, I'm going to start with 20. Which is square root of 4 times the square root of 5, which I'm going to now replace the square root of 4 with a 2. So that's 2 root 5. And I've got a 3 root 5, and those are the same kind. They're the same kind when the number underneath the radical is the same. Now let's work on this 45. I see a factor of 9, which is a perfect square, 5, and the square root of 9 is 3 root 5. Whoops, root 5. And so now you can see they're all the same kind. This tells you how many. This tells you what kind. So I have negative 3, positive 3 root 5. Those happen to just cancel each other out. And so my final answer is 2 root 5. Okay, number 8, cannot leave a radical in the downstairs of a fraction or in the denominator. And so what we do is we multiply it by a fancy form of 1. And that fancy form of 1 happens to be whatever makes this a complete radical. In other words, this is a complete square. In some cases, we might not be multiplying by a square root. We might be multiplying by a cube root. But that's just a fancy form of 1. And when you multiply your numerators, you get 3 root 2 in the numerator, and in the denominator you get the square root of 4, and the square root of 4 is 2, and so that would be your final answer. You've taken care of the problem with a radical in the downstairs. Okay, here's one, number 9, where we have a little bit more of a simplification here. Let me change out my color so it's contrasting. First thing you should do, if you can reduce on the front end, go ahead and do so. And since they both have the same number in the crook of the symbol, I can reduce this because they're both even numbers. I can change this to the 4th root of 3 over the 4th root of 4. Now this number tells me I have to have 4 of a kind. So I am going to take that 4 and I am going to write it as 2 squared. Alright, so now my fancy form of 1 has to complete the root here. In other words, I want my fancy form of 1 to be of such that it will give me 4 2's. Well, I've got 2 already. I need 2 more. So my fancy form of 1 is going to be, as you see. Now, when I multiply the denominators together, I have the 4th root of 2 to the 4th. And in the numerator, I'm going to convert that back to a 4, and 4 times 3 is 12. As you know, this number, when this number here matches this power here, they cancel each other out. And so that 2 steps out from underneath the radical. And in the numerator, oops, that should be a 4. Sorry about that. this will be 4th root of 12. And that's your answer. One more. Okay, so we're multiplying this, and excuse the train in the background, please. That's right by my house, and it's the evening time train. Alright, so as you multiply these out, you're just going to distribute the 6, but I want to show you something you can do with that 6 before you get to the 12. First, we're going to start by multiplying root 6 times 1, which is root 6. Now, watch what I'm going to do here. When I multiply the square root of 6 times the square root of 12, how about if I just break that 12 up into 6 and 2? If that freaks any of you out, just multiply those together, get 72, and then break it down again from there. But this helps me a little bit in the simplifying process, because this actually is going to be the square root of 36 times the square root of 2. And we know that the square root of 36 is equal to 6 root 2. Since these are not the same kind, we can only leave it just like this. I know it looks a little bit awkward, but that would be your final answer. And we'll do the other questions on the next video.